Okay, welcome to AP Environmental Science. I'm Mrs. DeWalt, and we're going to go through some key concepts in Chapter 1 of our energy unit, and also going to go along and show you some key things to look at as you're reading through the textbook. So, first chapter, we're going to be talking about environmental problems, their causes, and a key term called sustainability. You'll see all the key terms are highlighted in green, and you'll see the definition for sustainability and other key terms. This one is the capacity of the Earth's natural system and human cultural systems to survive, flourish, and adapt into the very long-term future. You'll also see that there's core case studies at the beginning of each chapter and throughout the chapters. A couple other key terms: environment, environmental science. The definition of our class is that is an interdisciplinary science, and it connects information from what we'll be studying in ecology, biology, geology, chemistry, along with information from the social sciences and humanities. Environmental science is the study of connections that are made in nature. We're going to look at how nature works, how we affect the environment, how to live more sustainably. Nature's survival strategies follow three basic principles, starting with our reliance on solar energy. Sun warms the earth, it fuels photosynthesis, which leads us to two, which creates our outstanding biodiversity, which then leads us to three, the chemical cycling or circulation of the chemicals from the environment to the organisms and then back to the environment, also known as nutrient cycling. Sustainability has certain key components, and one of them is natural capital, and then you'll see the term natural resources, which are useful materials, and natural services. And I think this diagram explains it quite well. Our natural capital equals the resources, which are shown in blue, plus the services that they provide. So you'll see a good example of land as a natural resource. And what does it provide? It allows for food production and the nutrient cycling. You can see an example of nutrient cycling from dead organic matter through the decomposition process into inorganic material in the soil or matter, and then organic matter in the plants and back into the animals. Another term you'll see is called degradation. You can see this is an example of a once large, diverse tropical rainforest. Those nice, clean, cleared lines are to grow soybeans, and this changes the environment. The resources, some are renewable and some are not. By definition, a resource is anything that we'll obtain from the environment to meet our needs. Some are directly available, like sunlight, which is also called a perpetual resource, and some are not directly available for use, such as petroleum. Renewable resources may take several days to several hundred years to renew themselves, such as grasslands or fresh air or fertile soil. And if we're using these resources, we use them at what's called a sustainable yield, which would mean we're using them at the highest rate in which we can use the renewable resource without reducing its availability. Therefore, it will remain sustainable. Non-renewable resources have their own category. We are starting with the energy unit, and they are an example of non-renewable, or several of them are, but also metallic minerals and non-metallic minerals. And I'm sure you're all familiar with the term reduce, reuse, and recycle. The term reduce uses the least amount of energy in that process. For reuse, you see an example here of bottles being collected and then reused for the same purpose. And then you can see the last one, recycle. This uses the most amount of energy or has the most steps in turning those materials into something else. And we will go through the laws of thermodynamics in our next section, talking about that increased amount of energy needed. We also need to look at countries and how they differ in their levels of unsustainability. And this is really dependent on several things: their economic growth, their GDP, or gross domestic product, which can then be divided up into what's called a per capita GDP, which would be the measure of their economic development. Economic development is using economic growth to raise your living standard, and what we'll get from that is two large divisions of more developed countries and less developed countries. Okay. You can see this map just shows the high income areas with the gross national income per capita all the way down to the very low in red. And with that, we can go into our next idea about how our ecological footprints affect the Earth. Environmental degradation, which is the wasting, depleting, or degrading of the Earth's natural capital, has been happening at an accelerated rate. Degradation, I know you've seen examples, things such as decreased wildlife habitats, shrinking forests, water pollution. And pollution of these, there's two categories of pollutant sources we'll talk about. One is point and one is non-point. And the types of pollutants can be degradable or non-degradable. We can control the pollution with either a cleanup or a prevention. So if you look at the point source air pollution here, a cleanup would be taking care of any harmful effects that occur due to it, and prevention would be, say, legislation to decrease the amount. Non-point water source pollution, you can think about again how you can decrease the number of bottles getting into the water, or you can stop them from happening before. Overexploiting of our shared resource is another thing we'll talk about, called tragedy of the commons. Okay, tragedy of the commons is the idea that if we have three types of property, our private property, our common property, and then our access to renewable resources, unfortunately the common property and the open access resources degrade from overuse. So we're going to be calculating our ecological footprint in class, and we'll be looking at the different per capita ecological footprints before we do that. And basically an unsustainable footprint means that it's larger than the biological capacity for replenishment. Okay, there are patterns of natural resource consumption, and this photo here shows a village in the Himalaya Mountains, and this one here shows an American family. And you can see that the United States has quite a big footprint when you look at it in what's called millions of hectares, and hectares is a term you want to become familiar with. And the way that they calculate this is called I equals P, the population, times the effluence, times the technology that's available. And when you look at a model of this, you can see that the less developed countries in terms of population is higher than more, but when you multiply it by consumption, the more developed countries are consuming much more. The technology can balance out depending on how you use what you have, and then it all equals our environmental impact of the population. There are some more case studies as you read. China is now the leading consumer of various foods and goods. It is our second largest consumer of oil, and 2/3 of most of the cities polluted are unfortunately in China. It is projected that they may become the largest consumers and producers of cars within the next decade. Okay, ecological tipping point. This is often an irreversible shift in the behavior of the natural system. Environmental degradation has some time delays. Our actions now, we'll see, a decade or two later, such as long-term climate change or species extinction. And we have increased our ecological footprint for several reasons. We started off as hunters and gatherers. We transitioned into our agricultural revolution, and now we're in what they're calling the information globalization revolution. So how do we have environmental problems? Well, there's four basic things. Our populations are growing. an unsustainable use of our resources, poverty, and then excluding environmental costs from the market costs. Exponential growth. First thing, human population. We can see we are just at around 7 billion, and the projection is unknown. Only time we've had a dip, you can see the Black Death or plague. Harmful effects due to effluents include high levels of consumption, but you can also flip it and see that if you are effluent, you actually would have the funding for developing the technologies to reduce things such as pollution. Poverty, harmful effects, population growth is affected, malnutrition, premature death, and then unfortunately having limited access to adequate sanitation facilities and clean water. There's extreme poverty, and you can see the harmful effects of extreme poverty and the number of people or percentage of the worldwide population that does not have enough fuel for heating and cooking, or even just something as simple as clean drinking water. Price is not included in the value of our natural capital. Companies do not pay the environmental costs of the resources that they use. Companies can receive tax breaks and subsidies, which are the two other keywords that we'll be talking about. And the economy may be stimulated, but there may be a degradation of natural capital. So, what is an environmental sustainable society? That meets the current needs while ensuring that the needs of the future generations will be met. We can work together to solve environmental problems with something called social capital, which encourages openness, discourages confrontation and polarization. A great example of Chattanooga, Tennessee, which was in 1960 one of the most polluted cities in the U.S. They had a vision, they set goals, and their revision as of 1993 has citizens working together and is one of the best and most sustainable places to live in the United States. Individuals do matter. Relying on our renewable energy, which we'll be talking about more in our energy unit, protecting our biodiversity, reducing waste and pollution. Capturing wind is one of the world's most rapidly growing and least environmentally harmful ways to produce electricity. And something as simple as this young child planting a tree. So quick recap of the big three. We could rely more on renewable energy. We can protect biodiversity by preventing degradation. And we can help to sustain our Earth's natural chemical cycles by reducing our production of waste. Thank you very much.